If the rumors are correct, and they are just rumors, then Apple is about to drop a bombshell which could turn the whole AI world on its head. Now, to be clear, I have no insider information about this. I'm just speculating based on what I've seen, the recent announcements from Google, Nvidia, and AMD. But it seems clear to me that the AI world has realized that local AI is the next big thing. But regardless of what's announced, it's going to involve chips because, as I've been saying all along, AI is more about hardware than software, and Apple has the best hardware in the world to run AI. To explain that, I need to explain why Apple chips are so good and why the rest of the industry has been desperately trying to move off legacy technology. So right now, the chip inside your iPhone and your MacBook, and increasingly the servers running the internet, is a fundamentally different kind of chip than the one that Intel and AMD have been making for 40 years. It's not just that they're faster or smaller, they're built with a different philosophy. And that philosophy, called RISC, was considered a fringe idea by most of the computing industry up until about a decade ago. Now, most people don't have the foggiest idea of what goes on inside your computer. So in this video, I want to explain in plain English what is the difference between RISC and CISC, where they came from, and why this architectural war is the real AI frontier. So CISC stands for Complex Instruction Set Computer, and RISC stands for Reduced Instruction Set Computer. Now, when the PC was invented, people didn't sit down and say, hey, this is a complex instruction set. That terminology was invented after the creation of RISC to explain what the world was like before the innovation that ARM produced. So the simplest way that I like to think about this is between a chef and a cook. Now, to someone looking into a kitchen, they might see just one person. But if that person is a chef, they've probably had way more training, way more experience, and have a whole lot more authority. In fact, the word chef actually comes from the French chef de cuisine, or head of the kitchen. So in some sense, chef is more a leadership role. A cook, on the other hand, is the name of the person who's actually doing the work. So now let me apply that to chips inside your computer. With a chef, you say, hey chef, make me a lasagna. That's like CISC, or complex instruction set. It's one instruction, and the chef knows exactly what a lasagna is, and they know all of the sub-steps, and they just go about and do it. Now, with a cook, you have to say, well, you need to make me some pasta, add some meat, put some bechamel sauce, and put it in the oven. And they'll make the lasagna the way that you like because they're following more specific instructions. Now, at first glance, you might say, but CISC obviously sounds better. One instruction versus 50. That's way less work for the programmer and less memory for the program. So that's why CISC won in the early decades of computing. But the catch is that CISC is enormously complicated inside. The chef has to remember thousands of recipes, and they're slower at individual tasks because they're constantly looking things up, and they consume a lot of energy because it's just that complicated. And like most chefs, they'll have some opinions about what tastes good.
An idiot sandwich. Idiot sandwich what? An idiot sandwich.
Now, the RISC cook, on the other hand, dead simple. They do the small things, but they do them incredibly fast, and they consume significantly less power doing it. So CISC came first. In the 1970s, memory was scarce and extremely expensive. So every byte of code mattered. So Intel, Motorola, and IBM built chips with rich, complex instruction sets. The famous x86 architecture that still powers most PCs today is a direct descendant of Intel's work from 1978. But then in the 1980s, researchers at IBM, Berkeley, and Stanford noticed something strange, which was they studied the software and found that about 80% of programs only used about 20% of CISC's instructions. So a British company called Acorn Computers took this idea and ran with it. So in 1985, they shipped the Acorn RISC Machine, which was ARM. And it was designed for a low-cost home computer. And one of its accidental virtues was that it used almost no power. The first ARM chip ran so cool that the engineers initially thought that the power meter was broken. So that low power trait turned out to be one of the most important accidents in modern computing. So when mobile phones exploded in the 2000s, ARM was the architecture that could deliver real performance from a very limited battery. So every iPhone, Android, smartwatch, all uses ARM. And ARM ships more chips per year than every other architecture. That's tens of billions per year. And then in 2020, Apple did something that the industry thought was really radical, which is they put ARM in a laptop. That was the M1 MacBook, and it was way faster than the Intel chip it replaced and used a fraction of the power. Data centers now consume 2 or 3% of global electricity, and AI is pushing that sharply upwards. The second is AI, and this is where Apple's bet has really paid off. Apple had been designing ARM chips for the iPhone since 2010, and they'd learned something really important was that when you control the entire stack, the instruction set, the silicon, the operating system, and the frameworks, you can design memory and compute to work as one system, not separate components fighting over a slow bus between them. And that's why the Apple silicon has unified memory between the CPU, GPU, and neural engine. Now, that means that AI models don't have to constantly shuffle data around. The model or the weights sit in one pool of memory, and every process can read that directly. Third is sovereignty and cost. ARM licenses its designs rather than selling finished chips. And that means companies, even countries, can design their own processors. China's doing it, Apple's doing it, Amazon, Google, Microsoft, they're all designing their own ARM chips. So the days of one company in Santa Clara dictating the world of computing is ending. So next time someone says that Apple Silicon is just a faster chip or that ARM servers are a niche play, you've got to remember the deeper story. This is a 40-year debate about how computers should be built. Do you give the chip complex instructions and let it figure things out, or do you give it many simple instructions and let the software be clever? And for decades, complexity won because memory was scarce and software was relatively simple. But now energy is scarce, software is sophisticated, and all that sophistication has moved onto the computer. So, therefore, simplicity has won. And that architectural shift is what's remaking laptops, phones, data centers, and the entire economics of AI itself. I'm Dr. Errol Brandt. Thank you for watching. And if you enjoy my content, please like and subscribe. I also love to read your comments and thoughts, even if you disagree with me. Thanks again for watching, and I'll see you in the next one.